what is it? He said, there is this equation which nobody knows how to solve. Next morning at breakfast, Wiener came with a solution. It was not completely correct, but they worked together. And it is now, the equation was invented by somebody else, Schwarzschild and Milne, but it is called Wiener-Hopf solution because the method of solution was so unique that people call the equation by Wiener and Hopf. And usually in mathematics, they use alphabetical order, but Wiener was so. So I realized this, and I found that somebody in astrophysics, Chandrasekhar, had discovered, or Ambatsumyan had discovered Riccati equation connected with Wiener-Hopf equation for time-invariant model. Anyway, I was able to use those ideas, and we found new results in Kalman filtering, which are quite widely used. So cross-fertilization is important. The other is, I learn from my students. Students learn from each other also. That's important. And I use postdocs because they have more time and they interact with the students and they teach me. So it helped to have groups of students. So that's all I can say. And you must have luck also.
Okay, any other questions and comments?
Tomorrow, let me close with this story. Any other question?
Just, okay, you have a story?
I'll close with this story. You know, I did work in mathematics, actually. We have a lot of new results which are useful in VLSI, by the way, and in OFDM communications as well. It's called displacement structure of matrices. So I used to go to linear, in fact, I'm quite well known actually in linear algebra also. So I met a mathematician called Auslander who heard me and said, this is quite interesting, and I must tell you that I'm going to DARPA, which is this big agency in the US which gives money for special projects and so on. Large amounts of money, the minimum is $1 million, whereas usually you get $100,000 from NSF and so on. He said, I'm going to DARPA to head the mathematics research problem. I like your results. Send me a white paper and we'll see what it is. So that was nice. I didn't hear from him for 2 years. One day I get a call in my office. I pick up the phone and I said, hello. Oh, this is Lou. I said, oh, where were you? So it took a long time to go from university to government. So he says, I'm in mathematics here, but the good news is I'm finally in DARPA. Bad news is the money is given away by my predecessor, so I have to wait for next year. Secondly, mathematics has moved from information technology to materials science. Why? And I think the general in charge of DARPA thought all M's should be together. So mathematics, materials science. So he says, I'm listening to all these talks about manufacturing of composite materials, lightweight materials, stealth aircraft, all based on physics and chemistry, but they have no idea how to manufacture. Very crude methods. He says, but control theory can be used, simulation. So I have no money for mathematics, but I have money for manufacturing. So I was silent for some time. I said, Lou, you know that I only write papers. Manufacturing, you have to do something. So he said, okay. He said, doesn't matter. I think these ideas are useful. And I also said, DARPA wants monthly reports. How can we, with graduate students, do monthly reports? He said, no, I don't want monthly reports. I won't read them. You write annual reports. And he said, I believe in it, so it doesn't matter. It's a long discussion. He said, I'll give you plenty of money, and doesn't matter if you fail. So we took this challenge, and I hired some new students, and I took 2 other faculty, one from semiconductors, one from control theory, and we got some new results in that field. So it was luck that from mathematics work, going to a conference, he went to DARPA and he gave me money for manufacturing. And we made it 2 companies out of that work also. So luck is very important. But you have to be prepared for luck. Thank you.
Let me also conclude with an interesting story. Tom, about 33 years ago, where I met him in Syria, he told me a very interesting story about Dr. Reza Aref. You know, originally he was supposed to work with Tom Kylab. He went to him, he asked for, you know, a PhD thesis. He wanted to finish his PhD thesis and come back to Iran as quickly as possible. Well, his response, Tom's response, was the same as what he told Babak. Okay, work in signal processing, communications, control, electrical engineering, etc. He didn't give him a well-defined problem to solve. So he decided to go and work with the late Cover, where he gave him a very specific problem, and then he solved it, and that was it. And he came back. And now I think you will see him tomorrow.
Right. Okay. I must say, we had some very good students. Aref was one, he worked with Go, but he took my classes. Dost Hussaini, who is now in Isfahan, and Koshu Lashkari, I think, stayed back. And then after that, we had very brilliant students from Iraq, Hamid Agajan, Babak Kalaj, Babak Hasibi, and others who have worked with this. So we are very happy to have students from Iran, especially from Sharif and Tehran universities. Thank you for coming.
Thank you very much for staying so late.
Yes, sorry.